Yeah.
And yeah, let me add something on the battery monitor and protector, because it's really interesting, the parts that we have, because they can also save a lot of money in with using our part, because we have a highly integrated IC with the high side driver for the MOSFETs inside, and also because we have this soft start capability feature, which basically means that you can avoid the pre-charge circuitry, because we control the gate of the MOSFET, right? For turning on these MOSFETs, we slowly increase the voltage of the gate, so the MOSFET allows a small current go through it, a control current, so it can charge the load, right? And we are doing this with the IC with any extra circuitry. So we estimated $0.6 for each battery pack that you can save using our IC, because we don't need this pre-charge circuitry. We are doing this soft start control, and I think it's very interesting. It's very interesting. Sorry.
And what is so it's a soft start, so you don't have to have circuit protection on over
like
a spike on.
Yeah. So what happens if you switch on the battery? If you connect the battery to a load, the load is 0 volts, right?
Right.
The battery is 28 volts. If you switch on the MOSFET, the current is going to be a very huge.
Right.
So
what's the current way that's handled?
Yeah, they need an extra pre-charge, what is called a pre-charge circuitry, which it's basically a MOSFET with big resistor, big in terms of it can dissipate a lot of energy.
Okay.
So you close this MOSFET, and with using this, you have a MOSFET and a series resistance. So you close this MOSFET, and the current is sinking through the load.
Okay.
Right.
And
So it's slowly.
ramps up.
Yeah.
Okay.
It ramps up. It's slowly increasing the voltage in the side of the load.
Okay.
But you need this configuration. You need the resistance, and you need the FET.
Right.
And the protections of the FET and everything.
Yeah.
So with our solution, you can avoid this. You don't need it. Why? Because we are ramping the voltage of the gate.
Right.
The way that the MOSFET is slowly closing, allowing a small current go through it, and slowly increasing the voltage of the load. So when the load achieves the correct voltage, we turn on. We close the MOSFET completely.
So it emulates a resistor MOSFET with actual just step up of.
Yes.
Okay.
Yes.
Very neat.
Yeah. And I mean, this is a unique feature that we have. I think no one is doing this.
Okay. Very cool.
That's really, really good for us.
Yeah, that's great.
Yeah.
Okay. I think we covered a lot of things. Hopefully, people become educated on fuel gauges and different solutions. But thanks for your time. It was great talking with you.
Yeah. Thank you to you. I hope they understood a little bit better what's a fuel gauge and why they need it. So I'm happy to help.
All right. Excellent.
Okay.
All right. All good.